Hello everyone, thank you for tuning into my video today on polynomial synthetic division. As you open up the notes for today, you'll notice that there's a couple warm-up problems. So at this point, I would encourage you to pause this video, try the entire first slide on your own, come back and check your answers when completed. Okay, here is hopefully what you came up with for all of the opener problems. Okay, so in our last video, we did some polynomial long division. And today we're going to take a look at a little easier way to do long division, but the stipulation is it only works when we are dividing by a linear term. Okay, so let's take a look here. Here's a problem we did yesterday, or at least something similar to what we did yesterday, and here's how we would do that using long division. Sure is a lot of work, right? And it works every time. It's nothing wrong with doing this, but there is an easier way to do this type of problem because we are being asked to divide by a linear term. Okay, so that's called synthetic division. So here's what we're going to do. We're going to take the root of this, so the opposite of this number, so that would be 3. I'm going to write that down here, 3. Then we're going to open up an elongated L-shaped figure here. And then next to that 3, I'm going to put all the coefficients of these numbers. So you got to be careful here. If there's any degrees missing, you have to put in a 0. We'll get to some of those later. All these degrees are here, so 1, -6, 4, 11, and 2. Fourth power, third power, second power, first power, 0 power. I'm going to put a little box right here to remind me that this is the remainder right there. All right, so here's how synthetic division works. You bring down the first number, so this comes right down here, 1. And then it's going to be multiply, add, multiply, add, multiply, add until you finish this line. So what do you multiply? This number times this number, and you put that here. Then you add these together, and you get -3. Then you multiply these numbers to get -9. Add these together to get -5. Multiply these to get -15. Add these to get -4. Multiply these to get -12. And add these to get -10. Okay, so our answer then is just one. We start with 1 degree lower than our original problem. So our original problem was a 4th power. So our answer here is going to be a 3rd power. And these are the coefficients of that polynomial. So it's going to be 1x to the 3rd minus 3x squared minus 5x to the 1st minus 4. Remember, this is your remainder. So it's going to be minus 10 over x minus 3. And would you look at that? It's the same answer we got via long division, but we just saved a whole lot of time and a whole lot of space. So observations here, what does the final result of -10 represent? That is our remainder. So that tells us that this is not a factor of this. What do the set of the numbers 1, -3, -5, -4 represent? Those are our coefficients of all the degrees of x. Okay? So a question you might be thinking right now is, why in the world would someone teach me long division when I can just do this? Well, again, that goes back to what we are dividing by. We can only use synthetic division if we are dividing by a linear factor. If it's anything that's not linear, we have to use long division. All right, let's take a look at another problem. So it's important to notice that coefficients for every power of x less than or equal to the degree must be written, or something will go wrong. That means if a term is missing, the coefficient is 0, and we have to put that 0 into our synthetic division. Observe what we see here in number 2. So we're dividing by a linear power, here linear term. a linear expression. So we're going to go ahead and use the opposite of that, which is 1. Open up my L shape here. My coefficients are 2, but you notice there's no cubic term here. So I have to put a 0. And then 1x squared. There's no linear term here. So I got to put another 0. And then my constant's negative 5. And now we do our synthetic division. Bring down the 2. Multiply, add, multiply and add, multiply and add, multiply and add. Ooh, there we go. So our final answer when we divide here is going to be 1 less than this degree. So it's going to be 2x cubed plus 2x squared plus 3x to the first plus 3 minus 2 over x minus 1. A couple more examples. So it looks like we can't use synthetic division on A, but in fact we can because the denominator, we'll get there in a second, even though the denominator is a quadratic, we can factor it into 2 linears. So really, this just means divide it by it twice, one at a time. It doesn't matter which one you start with. We can start with negative 5 or positive 2. I'm going to start with positive 2. So bring down the 2. Multiply and add, multiply and add, multiply and add, multiply and add. And our remainder is 0. Now we got to divide by negative 5. But when you divide by a second factor, we're going to use what we just got as our answer. We're not going to use the original coefficients. We're going to use the new coefficients. So bring down, multiply, add, multiply, add, multiply, add. So our answer here is going to be 2x squared minus 7x plus 30 minus 146 over x plus 5. All right, and then let's take a look at one more. So remember, the 0 here is going to be negative 5 halves. So we're going to go negative 5 halves, 6, negative 15, negative 87, negative 30. Bring down the 6, multiply, that would be negative 15. Okay, then we get negative 30. Multiply, that would be positive 75. Add those together. And multiply, we should get 30, which adds together gets 0, which means this is a factor. So what we're left with is 6x squared minus 30x minus 12 with a remainder of 0. Okay, at this point, the last slide is some extra practice. I would encourage you to pause this video here, try the last slide on your own, come back and check your answers when ready. Here are your answers for the last 4 problems. You can pause the video for as long as you like to look at this here. Otherwise, thanks as always for watching my video today, and we'll see you again soon.